All right, let's get it. All right. So we're looking at number 7. We have an equation. Let's find this stuff and sketch a graph. Now, for some people, they want to find this out first and then sketch the graph. For some people, they would sketch it and then dictate kind of what happens. I'm going to go through and find all this stuff first. Okay? So, I know they want asymptotes, and they're going to use a formula. What I would do, though, is I'm going to find my period first. Does that make sense? So my period would be pi over 1 over 4, right? Because that's my b. So I got 4 pi. Do you agree on that? Okay. Now I have to ask myself with this. Are my asymptotes affected by a vertical stretch and a vertical shift? No, they're only affected by horizontal stuff. So for tangent, my asymptotes are half on one side, half on the other, right? So what's kind of like half my period? 2 pi. So where's my left asymptote going to be? Negative 2 pi. And my right asymptote is going to be positive 2 pi, right? Because there's no shift. If there's a shift, I would just apply it to those, right? Now the other thing you could do, the other way to do this is you take your x over 4 and you set equal to pi over 2 and you solve it and it'll give you your left and right asymptote. I don't like the formula way because you'd have to memorize it. I like to just think about how the graph works. Does that make sense? Both ways will give you negative 2 pi. Oh, well, yeah, you'd say equal negative pi. You know what I mean? I don't do it this way, but you can. All right, what other transformations are occurring? A vertical stretch of 3. And a vertical shift down 2. Okay. All right, I'm going to graph, like, at this point, I'm going to graph it and kind of see what's going on. Yes, I'm going to graph it up here, not down there, but it's just easier to see for you guys. So, where's my 0, 0 is usually here, but where's it going to go?
0, 2.
It's going to go down 2, right? Do you see that? Because the shift down. Am I still going to open up and down? Or am I going to be increasing the whole way? Yeah. Like that. Because it's not negative. Now, what's this point going to be right here? It's going to be something 1. It'd be, what's half of 2 pi? Pi 1, right? Because this was at 2 pi, negative 2 pi. We're just sketching it. It just wants a sketch. And down here would be what? Negative pi, negative 5, right? Because I went down 3. Okay? I don't even need to know those. Those aren't even going to come up. But it's just a reminder how to do it. Where am I concave down? Right here, I'm concave down, right? So from here to here. So from negative 2 pi, right? Am I doing this right? Yep. 2, 0. No bracket on negative 2 pi because I don't exist there. Where am I concave up? 0, 2, positive 2 pi. So because of that, what's my inflection point? 0. 0, 0, negative 2. Why did they do that? Why did they use parentheses for this? And like that's a point. So that's a point. That's an interval. Makes sense. Is everything? Oh, where are the points of inflection? Not the point, it wants, ooh. Yeah, but what if I want to list all the points? It'd be 0 plus pi k negative 2, right? Oh, not pi k, my bad. Why 4 pi k? Period. Where k exists as an integer. Yes. Yeah.
Yeah, for the second little line on the Z.
Yes.
Like, how important?
This is a variable. That is a set of numbers. That means integers.
So, like,
How about this? Let's say you guys don't like this. You could just say k is an integer. That and this mean the exact same thing. Why is that wild k? Is that better? What about this? What about this?
yes. So it's like a part.
I'm doing my best. It's my first day. Yep. Oh, kind of, yeah. For my people. For my people. I got you. I got you. I got you. All right. Let's do this one. You gross. It's not. It looks worse than it is, right? Like my cooking. I don't like the order they do this. Let's talk about the transformations first. How about that? Let's do these two first, and I'll use that to explain the rest. So would you agree I'm going to go left pi, right? Up 1, right? I'm going to reflect over x, right? And vertical right?
The number was smaller than one.
Yes. Now, why aren't we doing anything horizontal? Because I'm going to do that period. So what's my period going to be on this one? It's going to be pi over 1/2, right? Which is 2 pi. All right, now, again, you can do this the formula way for left asymptote. You take this. I'm going to show it to you. You can take this and set it equal to negative pi over 2 and solve it for x to see what the new asymptote is. That's not how I do it. You can do that, though. What I would do is I'd think about it. I would think my normal asymptote is at, well, I would move my 0. I tell you guys, I move my 0 and then move the asymptote around it. So I don't need to do this part. I'm going to do this. Where's my 0 going to go? My 0 is going to go up 1 left pi, right? 0 goes up 1 left pi. So I'm going to go up 1 left pi, and that's my 0, right? Now my asymptote, or my period is 2 pi, right? So it means I have an asymptote pi to the right, pi to the left, right? So if I go pi to the right, that's 0. If I go pi to the left, it's negative 2 pi. So my left asymptote would be negative 2 pi. And my right asymptote would be, you guys see how I do that? I move my 0, because that, does your 0 get affected by stretches, shrinks? No, but it gets affected by shifts, right? So I move my 0 and I go half on one side, half on the other. Okay. All right, is that enough to graph it actually? Yeah. So now I'm going down this time. Do you agree on that? Because it's negative. I cut these in half. I don't need those points. What's up? All right. I moved my 0 up to 1. So this would be negative pi over 2, right? What's my a on this one? 2. So my a is 2, so it's negative 2. Oh, yeah. Thank you. Because I go down 2 from that point. It'd be negative 1. Thank you. And then I'd go up 2 from that, so it'd be 3 pi over 2 negative positive 3. Good catch, good catch. All right, where am I concave down?
0. Negative pi to 0.
Negative pi to 0? Asymptote gives you parentheses. Where am I concave up then? Yep. And then what makes my point of inflection? Yep. Now, do they want all of them? Yeah. So how would I write that? It'd be negative pi plus 2 pi k 1 where k exists as an integer.
All right. Yeah.
Hold on, we had to graph 2 of those. So where I go over 2 pi to pi. And that would be 2 pi. It told us to in the top part. Graph 2. Yes.
So when you're solving for that left asymptote, why did you say it was a negative pi?
Because that's where the normal one is.
Oh, okay.
The normal one is negative pi over 2. So you can set equal negative pi over 2 and pi over 2, and that'll give you your asymptotes. Oh my gosh, look at number 9. Wait, why am I not doing 10? That might be a typo. Hey, Tom. I think I'm going to, for funsies. I think I'm going to do it for funsies. Because I'm having fun. Actually. Oh, just matching. Actually, do you guys, how about you guys try 9 right now? You guys give 9 a try. Work. Yeah, we'll talk about it. Try 9. Work with someone around you, ask them questions. Mom, pause the video, come back with the answer. I want you guys to try that one though. Perfect. All right, let's see how you did out there in the stratosphere. I got C. For my Canadian fans. B. D. Not bad? Okay. Okay. Let's do example 10 then. All right, look at this beast. All right, what do they mean A and D? Remember, it's A I know I write this all the time. Oh, I got passed back. I'm on your guys' test. Guys, remember, B has to be on the outside of those parentheses for X plus or minus C. You have to factor it out first so you know what the actual shift is. That was the one of the number one mistakes made, except by some certain people.
What?
All right. What's the first thing I'm going to look for tangent graphs? Zero, but zeros are goofy. Asymptotes. Is it easy to see asymptotes on the tan? Yeah. Now, if these were passing through, if they weren't shifted, I would do that. But obviously, they're shifted, right? So asymptotes by easiest thing to see on this one. Because where is my zero found? It's right in the middle of my asymptotes, right? So if these are my asymptotes, 1, 2, 3, 4. Wait, 1. So my zero would be right here, right? In the middle. So this is my zero. Does that make sense? It's always right in the middle of my asymptotes. So because of that, that point is 1, 2. Okay. I wasn't done writing it. It was pi over 4. 2. Oh, right. So does that give me my D? My D is 2. I went up 2. Okay. How do I find A? It is. So I'm going to go over. When I go over to the middle here, and I go over to the middle here, what's that point? Is that 1.5? And so how much did I go down? By 0.5 or a half, right? So what's my A going to be? 1/2 or 0.5. Does that make sense? I went down 0.5, up 0.5. Ooh, this marker is stinky. It's always halfway. You cut it. You cut those in half between your asymptote band. Remember, you cut in half and then cut in half again. You quarter it up. A quarter of beef. All right. So what's my period on this beast? I go from pi over 4 to 3 pi over 4. So how big is that? Pi. I agree. Could you also count your zeros? You count your There's a lot of it. Stephanie Eraser almost took me out because it stopped my shoe from sliding. That actually, yeah, that scared me. All right, where do I get my phase shift from? My 0, right? I went right pi over 4. This is the hardest tan one you could add. What is my point of inflection? Oh, you guys want to do all of them? Yeah. Plus pi k, comma, 2. Wait. Whereas k exists in the set of the integers. Is this everything I need for my equation? What's my A? 1/2. Positive or negative? Positive because it's increasing. 1/2 tan. What's my B? Did my period change? So my B is just 1, unchanged. So I'm going to do x plus pi over 4 minus pi over 4 plus 2. The end. Don't worry. It's not too bad.